Hey, greetings grade 11s, this is JP. This is the first part of a series of lessons on the reduction formulae. I don't know how many parts there are yet because I haven't done all of them. So we're going to start by just revising the different quadrants. So what you've been doing for the last day and a half, 2 days, and just build on that concept. Let's start by looking at this GeoGebra applet. So what we've got, if we've got an angle in the first quadrant, like we've got the 60 degrees, we notice that the ratio of sine is positive, the ratio of cos is positive, and the ratio of tan is positive. Okay, so what will happen if I, of course, move this point around? So do you see, so as the point B is moved, remember, OP is the radius. Do you see, it doesn't matter where it is there in the first quadrant, sine, cos, and tan's ratios are all positive. Why? Because you've got a positive x, you've got a positive y, because it's in that first quadrant, right? X is positive, y is positive, and the radius is positive. If we move it over to the second quadrant, what happens now? Well, x is negative, right? Your x values are going to be negative, the y values are positive, and the radius, of course, is always positive. So what happens is, if I move this point around, you would notice on the right top corner, the sine's ratio will remain positive because it is the positive y over the radius, which is positive. Cos's ratio would be negative because x is negative over the hypotenuse, the r. And tan would also be negative because you've got a positive y over a negative x. Okay, so if we move into the third quadrant, what happens then? You'll notice that sine's ratio is negative, cos's ratio is negative, and tan's ratio is positive. Why is that the case? Of course, because in the third quadrant, we've got a negative x value, right? A negative x value and a negative y value, and then, of course, that positive ratio. Okay, that's an absolute value of that length. Okay, so what does that mean? That would mean, yeah, exactly like what I said, that you've got tan is positive because you've got a negative y divided by a negative x. So therefore you've got a positive tan ratio. Okay, the rest are all negative. If you move over to the fourth quadrant, you'll notice the positive x and a negative y. So that is why cos is positive, because x divided by r is equal to will be positive, y is negative, y divided by the hypotenuse, the radius is going to be negative, and so that will be sine, and tan would also be negative because y is negative, so y divided by x there would be negative. So in the fourth quadrant you notice that only the ratio of cos is positive. Okay, so let's look at this. So we've got 4 quadrants, of course, think of 4 square. So we've got quadrant 1, and that is, of course, going to be between 0 degrees and 90 degrees. Remember, we're going in the anti-clockwise direction. And then quadrant 2 is between 90 and 180 degrees. Quadrant 3 is between 180 and 270 degrees. And quadrant 4 then is between 270 and 360 degrees. What's very important here is that our default ratio, if we're looking at the default mode, is going to be triangles where the angle goes in an anti-clockwise direction. So it looks like that, right? You're going to get, you can see it like almost as a bow tie effect, right? So each of these triangles would border the 180 degree line, the x-axis, and it will be a point then in the different quadrants. Does that make sense? So in other words, we avoid drawing a triangle where one of the sides are touching the y-axis, so something like that. Just for now, we're going to do that a bit later. Those are called cofunctions. We're going to try to avoid that. We just want to have our triangles in that form. Okay, so what happens is, and this is from your textbook, so full-on page plagiarism here. So in the first quadrant, you just have theta, right? And you've got your x, y, and your r. Everyone is positive in the first quadrant. It's happy days. And then in the second quadrant, so this will just be theta, right? In the second quadrant, it will be 180 minus theta. That's another way to say you're, of course, in the second quadrant. It's 180 degrees minus theta. So what happens in the second quadrant? Only sine will have a positive ratio. Cos and tan, they have negative ratios. Then in the third quadrant, you've got 180 plus theta. That would mean that, so in the third quadrant here, so that would mean that x is negative and y is negative. That means that tan has got a positive ratio and sine and cos, they are both negative. And then lastly, in the last quadrant, yeah, so what we've got is we've got a negative sine, like I said, we've got a negative tan, and we've got a positive cos, and that would be 360 minus theta. Okay, so that's important there. Okay, so let's look a bit at the notation of this. So in quadrant 2, you're going to get so that's located there, of course. So you're going to get sine of 180 minus x, or any. So if there's a triangle there where that is an angle x there, right, you're going to get a sine's ratio is going to be positive, so that would be sine of x, or sine of theta, if it's 180 minus theta. You're going to get cos of 180 minus x, that is going to be a negative cos ratio. The cos x's ratio there would be negative. And then tan of 180 minus x, it will have a negative tan ratio. So, in other words, if you've been presented with a question, sine of 180 minus x, the 180 minus x, right, this part here, is indicating which quadrant. The ratio of sine in that quadrant is positive. The ratio of cos in that quadrant is negative. And the ratio of tan in the second quadrant is also negative. Only sine has got a positive ratio. In the third quadrant, so we're going to, that's where it's 180 degrees plus that reference angle, right? So your triangle would look something like that, right? Where x is there. So an example would be sine of 210. X is going to equal to 30 degrees, right? So what happens in the third quadrant? Only tan's got a positive ratio. So that would mean the ratio of sine in the third quadrant will be negative, right? It's sine 180 plus x is equal to minus sine x. And cos 180 plus pi x, cos's ratio is also negative. It's tan's ratio. You're going to get a positive tan there. So tan 180 plus pi x is equal to tan x. Okay, so that's located in the third quadrant. Okay, so let's look at what happens in quadrant 4. So quadrant 4 is 360 minus that reference angle. So you're going to get a triangle like that there, right? So where that's your reference angle. Okay, so sine 360 minus x, who's positive in the last quadrant again? Cos. Cos will have a positive ratio, so that's cos x. But sine and cos, they're a bit negative, eh? Like some of you, when you see me. Yes. So we've got a negative sine x, a negative tan x, but a positive cos x. Alright, so what do we have? Okay, so let's just revise this quickly. So in quadrant 2, sine 180 minus theta, that is the same as just saying, well, that is sine x. Sine 180 minus x is the same as saying just sine x. Cos 180 minus x is the same as saying minus cos x, right? And then tan 180 minus x is the same as saying minus tan x. That's in the second quadrant. 180 plus pi x is located in the third quadrant. Sine is negative there, so it's minus sine x. Cos is negative in the third quadrant, so that's minus cos x. But tan, hey, positive baby, so that is equal to a positive tan x ratio. Last quadrant, 360 minus the reference angle. Sine, very negative, right? Cos, very positive, so that's a positive cos x. And then lastly, tan is going to be also a bit negative there. All right. Before we move on, I just quickly want to pause. Just that two very important trig identities that you've seen you've explored last year, but I just wanted to remind you of those. The first one is sine square x plus cos square x is 1, and then the second one is tan x is equal to sine x divided by cos x. So first of all, what is an identity? An identity is an equation that is always true for as long as for any given values, as long as these angles are of course the same. So in other words, sine square of any angle, okay, think of that angle, plus cos square of that same angle is equal to 1. That's always going to be the case. Similarly, in the same way, tan x is equal to sine x divided by cos x. Tan of any angle is equal to sine of that angle divided by cos of that angle. Those angles must just be the same. Okay, so let's just remind ourselves why. The ratio of sine x is equal to y over r, opposite of our hypotenuse, so it's the opposite of our hypotenuse square, y over r. Cos x, x over r, adjacent of our hypotenuse, so it's x over r square, right? What is y, okay, so if we've got y over r all square, so that is y square over r square, plus by x square over r square, okay? And then what do we have then? Well, the denominators are the same, so we've got y square plus by x square. But in all these triangles, right? So if this is your r, and that is your x, and that's your y, what is x square plus y square equal to? X square plus y square is equal to r square, right? These are right angled triangles, it's Pythagoras. So therefore, what is y square plus x square equal to? That is going to equal to r square, so r square over r square, and that is equal to 1. That's why it's an identity. It will be for any given angle as long as this angle is the same. Sine square x plus cos square x is equal to 1. So we can play around with this identity a bit. So in other words, we can get sine square x is equal to 1 minus cos square x, right? If you minus cos square x on both sides, or we can say that cos x is equal to cos square x, is equal to 1 minus sine square x. Okay, so those are two valuable ways to convert it. And then of course we can square root on both sides as well, but let's just keep that for now. Okay, the second one, tan x is equal to sine x divided by cos x. Why is that the case again? What is tan x equal to? Tan x is equal to y over x, right? Opposite of our hypotenuse. Good. And what is sine x equal to? Okay, so here we've got sine x divided by cos x. So what is sine x equal to? Sine x is y over r divided by cos x, which is equal to x over r. So remember, if I divide, multiply with the reciprocal. Ooh, reciprocal. So therefore you've got y over x. Do you see? Y over x, they're exactly the same. So tan x is equal to sine x over cos x, right? And then there's a couple of ways you can manipulate that as well, of course. But just important here, whenever you see a tan x, you know that you can write it as sine x over cos x. Okay, so that's kind of a useful tip. Talking about degrees, I see I missed the degree sign in quadrant 3, and I'm too lazy to type it out again. Do you know where the hottest place in a room is? Have you ever wondered? Where in your room, where's the hottest place? Where would it be the warmest? It's in the corner because it's 90 degrees. We're now going to look at 2 examples. So the first question, and this will just give you a bit of a skrik. So 3 cos 180 plus x times by sine 360 minus x divided by sine 360 plus x times by cos 180 minus x. Okay, so what do you do? So what's better than doing one question? Doing 4 questions at the same time. So we've got 4 questions here. We've got cos 180 degrees plus by x. We've got that part. Let's make them all different colors. And then multiply that answer by sine 360 minus x. So that's purple, I think. And then we've got sine 360 plus by x, all right? And then lastly, we've got cos 180 plus by x. Okay, good. So, and then 3 times by all of that. Okay, so let's do this. So we're going to solve this question, right? And there's 3 components to it. So cos 180 plus by x is going to give us a ratio for cos, right? And then we're going to get a ratio for that sine 360 minus x, okay? A positive or negative ratio. And then, so there's 4 elements, right? Sine 360 plus x and cos 180 minus x. Okay, so I'm looking at you, all right? Are you ready for this? Yes, don't fear this. Embrace. Okay, so the first part, cos 180 plus x, which quadrant? So this part here, eh? Cos 180 plus x, which quadrant am I finding myself in? 180 plus by x, haha, quadrant 3. Who's positive in quadrant 3? Tan. Is that a tan? No. So therefore, cos 180 plus by x is going to be, the ratio of cos is negative there. So that's a negative cos x. All right. Then sine 360 minus x. Which quadrant am I finding myself in? Quadrant 4. Is sine positive in quadrant 4? No, heck no. Cos has got a positive ratio. Sine's got a negative ratio. Yes. So that is minus sine x. Sine 360 plus by x. I didn't teach you that, hey? No, man, of course. What is 360? That's the same as 0. What is that? That just means then there's a triangle, yeah, right? And that's in the first quadrant. Okay, so 360 plus by x is in the first quadrant. Who's positive in the first quadrant? No, they're all positive. Ooh, everyone's positive. Yeah, so let's not make a joke about that. So then sine 360 plus by x, that is going to equal to, so it's in the first quadrant, sine will have a positive ratio there. So positive sine x. Right. Okay, last part. Cos 180 minus x. Where am I finding myself? In the second quadrant. Is cos positive or negative in the second quadrant? Cos is negative. Sine is positive there. So that would be equal to minus cos x. Minus cos x. You have something like that. Okay. So what now? Now this is just simple algebra. Okay, there's nothing to this. Right, this is all one term. So what we've got here is we've got 3 times by something, divided by something, times by something. All right. So first of all, I would sort out the sign. How do you spell sign? S-I-G-N. I would sort out the sign first, right? Is my answer going to be positive or negative? What did you say? Is the answer going to be positive or negative? I can't hear you. Come, talk to me. Is the answer positive or negative? How do I know? Oh, that's a good question. So what we've got is we've got a so 3, so that's a plus 3, times a negative is a negative. So that answer is going to be negative. And a negative times a negative is a positive. And what happens on the denominator? We have a positive times a negative is a negative. So on the numerator, we've got a positive, and on the denominator, we've got a negative. And what is a positive divided by a negative? It's a negative. So answer is going to be negative. That's what I normally do first. Okay? I sort out my sign first. Will my final answer be positive or negative? Because then I don't need to do it. I think you'll see it actually makes life a bit less complicated. Life is complicated enough. All right. So let's go for this. Let's go for it. So we've got a 3 there times by. Okay, so now what we've got is we don't need to worry about this negative, the negatives and positives. So this is all one term. So what is cos x divided by cos x going to be equal to? That is going to equal to 1. They don't cancel. They divide. There's no operation called cancelling. They divide. Cos x divided by cos x is 1. What is sin x divided by sin x equal to? Yes. It's also equal to 1, right? Oh goodness, they don't cancel. If one of you says cancelling, I will find you. So what we've got is in other words minus 3 times. Oh my goodness, everything divided. So minus 3 times by 1 divided by 1, right? And that answer therefore is just minus 3. So the rest is just like algebra. If the question was what is 3 times by minus a times by minus b divided by b times by minus a. That's the same question. A is now just cos x and b is equal to sin x. So how would you do this question? You would say, well, first of all, my answer is going to be negative, okay? And what is a divided by a? It's 1. And what is b divided by b? It's 1. So therefore, the answer is going to be minus 3 over 1, and that's just minus 3. So that's just a bit of algebra. What do you do before that? You check at each of these ratios whether they're positive or negative. Okay. My grade 11s told me I'm not sweet enough in the videos, that I'm not encouraging enough. So this is my attempt. If you understood this, well Well done. I would never have thought that you would be able to do this. So if you didn't do this, if you didn't get this the first time, fear not. It will get better, promise you. So I'll do a couple of more examples. So if you did it, yes, give yourself a high five, not someone else, because yeah. But if you didn't get this, stay tuned for example 2. Well done for sticking with me. Okay, guys, hope you're feeling good. I know you can do this. Hope you're well. Let's do question 2. So we've got sine square 180, hopefully this is helping, sine square 180 plus by theta plus by cos square 180 minus theta, and then tan 180 minus theta and divided by cos 360 degrees minus theta. Okay, so what is sine square 180 plus by theta? What does that mean? Okay, so what that simply means is you're going to work out the ratio of sine theta, sine 180 plus by theta. So you're going to say, what is the ratio of sine 180 plus by theta? And you're going to square that answer. The same way with cos square 180 minus theta. That means it's cos 180 minus theta, and that answer square. All right. Hopefully that makes sense to you. So it's not the angle square, it's the function square. So let's talk about that quickly. So that's kind of an interesting thing. What will the sign be if a function is squared? So what will the ratio be? Would it be a positive or negative ratio if a function is squared? Yes. I could sense that you were thinking that it is a positive ratio. I could sense it. Why do you think it's a positive ratio? Well, so let's do this quickly, and I think you'll notice here. So the first one, sine 180 plus by theta, is in the third quadrant. So that would mean sine is negative there. So that's minus sine theta square. Right? And then cos 180 minus theta is in the second quadrant. Sine is positive there, cos is negative. So it's minus cos theta square. All right? And then on the bottom there, tan 180 minus theta is the second quadrant. Sine is positive there, tan is negative. So that is minus tan theta. And then times by cos 360 minus theta is in the fourth quadrant. Cos is positive there. So that is positive cos theta. Okay, so what does that mean? Minus sine theta all squared means minus sine theta times minus sine theta is of course going to be positive sine square theta. You're going to get a positive ratio. If you've got a function square, you're going to get a positive ratio because a negative times a negative is a positive, and a positive times a positive is a positive. All right, so that's good. Yes, and then we're going to get minus cos theta all square is equal to cos square theta, right? Minus cos theta times minus cos theta is positive cos square theta, and that all divide by, and we've got here a negative tan theta. If you've got a negative tan, it means you're a bit pale, and then times by cos theta. All right. Now, I told you earlier there's a couple of identities you just need to know. Remember the two different identities. What is the first one? Well, remember that. So sine square theta, remember the two identities, sine square theta plus cos square theta. As long as those two angles are the same, if you square a sine ratio and the cos ratio, the answer is 1. And then the second identity is tan theta is equal to sine theta over cos theta. Okay, so if we use that knowledge now, so first of all, what is sine square theta plus cos square theta going to equal to? That answer is going to equal to 1. And then we've got minus tan theta. What is minus tan theta? So that is then, okay, so first of all, our answer now is going to be negative, right? Good, we've got a 1 on top. And here we've got a negative ratio times a positive ratio. So our answer is negative. So what's another way to write tan theta? Is to write sine theta over cos theta, all right? And then times that by cos theta. And what is that equal to? All right? What is that equal to? I can hear you. Yes, so that is over 1. So what happens then? What is cos theta divided by cos theta? That is 1. So what do we have here? We've got negative 1 over, and what is on the denominator there? Sine theta. So that's a good answer. Okay, what is the same thing as saying 1 over sine theta? Yes, yes. I could sense that you might be thinking something mathematical. So it's cosec theta. Yeah. So minus 1 over sine theta. Another way to write that would be say minus cosec theta. But we this is fine. We don't want a tan in our answer. It's a bit it's a bit dark. So we want to write our answers in terms of sine and cos.